Hey guys, welcome back to my Java tutorial series. Today we're going to be delving into the amazing world that is variables. I know I've kind of touched upon them before when we did our methods, and I think possibly when we did our objects as well. I can't quite remember. But no matter, we're going to be exploring them nearly completely today, and then either my next video or one after that will be finishing up variables because I won't be able to touch on most of one of them today. And the one that I'm going to start with is that one that I'm not going to explain completely, and that is an instance variable. So objects store their data in instance variables, and an instance of a class is an object of that class. It's Actually, let me show you what I mean here. So I'm going to create a new class and call it counter. Don't know why that space is there, but whatever. And what this class does is represent a counting device, I suppose. So if you go to a theme park, for instance, and the turnstiles that you have to go, like each time that's turned, uh, a counter might be activated and one will be added to that counter. So, you enter, okay, one person goes in, add one to the counter, the person behind you goes, add another to the counter, etc., etc. Life goes on. So this is actually going to be a custom object, and the reason I said why we're going to be doing instance variables later is because I'm going to have a video that really describes exactly what we do here with this instance variable and what it is, what it means really to create your own object. But without further ado, let's get into an instance variable. So when we have a counter, there's really one thing we need to keep track of, and that's the number of items that are counted, or number of people that are counted. And I'm just going to call it value. I'll explain why I use private beforehand, and int I think should be pretty self-explanatory. You're just counting up by one, and you're not counting like a half of a thing. You can't just say, oh, half of a person went through. No, just a full person went through. Here we have our instance variable, private int value. There are three things that in every instance variable needs. You need your access specifier, and for instance variables, that's commonly private. We'll discover why private later, but let's move on to the second part, and that is the type of the instance variable. In this case, we're using int, and the identifier of the instance variable. Uh, Identifier is just a fancy way of saying this is the name of the this is the name of the variable, and its value in this case. So each object in a class has its own set of instance variables, and if we don't initialize them, that is, we don't give them a value, then they have a default value of 0. So if we have two objects, like if we're counting people at a concert, if we have an object called concert counter, that this is a counting object. If we have concert counter and boarding counter for like a plane or something, and they're two objects of the counter class, then each will have its own personal instance variable, in this case value. That means if I'm using my concert counter, then I can use like concert counter get value, and it would return how many people enter the concert, and that would just be this value. This value can be used for multiple objects of the counter type, I suppose. Multiple counter objects. So what's really interesting, I find, is that this allows us to create like one class, let's call it counter, and use it for so many different applications. That's the cool thing about Java, and this is actually getting into a more advanced topic that I won't get onto for probably several videos. Um, and that's pretty much like the flexibility of a program. Java is really good at making a program flexible. What I mean is, I could have it's flexible because it can be used for so many different things. And I know that was a lot of redundant phrases. However, I really want to get the point across of how you don't have to write like 1,000 lines of code when you can only write 100. It just saves a lot of time on your end and on the compiler's end. Excuse me, on the compiler's end. So now that we have our instance variable, we're probably going to want to be able to use it. Trying to think if I want to do the methods now or when we go over custom objects. I'm going to make the methods when we go over custom objects. I'm going to backtrack to when I said like this is private for a reason. I'm going to explain that and then we'll go on from there. So instance variables should be declared as private. Why? Because we do not need to edit the information stored within them unless it is explicitly done in their class. So I'm not going to be using this value if I'm like counting someone at a concert. No, I'm going to have our concert counter access this value and manipulate it only in this class. Also, this greatly simplifies the programmer's work when diagnosing errors. If you have a massive program that has a small error regarding some internal data of an object, you only need to look at the class pertaining to that object. So, if we have some large program for that concert counter, and we know that there's something wrong with like how many people it says entered the concert venue. So if like we have an attendance of I don't know 40,000, let's say it's a big concert. If we have an attendance of 40,000 people, and that's how many tickets we sold, but the counter says that 60,000 people entered the venue, there's going to be some sort of a problem, and we can know, oh, well, that's a problem with the value. That's the problem with the amount of times the counter was incremented. So then we can go right ahead and say, all right, the problem lies in the counter class, and we'll search there first. We don't need to like go like method by method through the program with like debugging software to figure out what went wrong. It's actually really great that way. So this process of hiding implementation details and providing methods for data access and really just making your program simple and simple to diagnose is called encapsulation. And I'm going to try and find some website or whatnot and leave that in the description below so that it can be like explained more thoroughly because I'm just touching upon it right now. But moving right along, so that's like basic scraping the surface of instance variables. As I said before, I'm not really going to go in depth on this one. I'm going to save that for our custom object class. So the next variable we're going to be talking about is a parameter variable. These ones are actually pretty nice and simple. So I'm just going to create a new class and I'll use the age-old example of a bank account and spell that right. And let's say we have some methods that our bank account needs to do. So let's say that we have some variable checking that contains a reference to an object of type bank account. So let's say we already have our bank account object, and so let's just say that this is a thing. Bank account checking equals new bank account. Let's just say that that's a thing and it belongs to the bank account class. This is an incorrect, um, actually, is it? No, it's not an incorrect declaration, construction. It's just not one that's recommended. So, let's just say that this checking is a bank account and it stores how much money you have in some account that belongs to you. But that's not important right now. What is important is that let's say that you want to deposit. Let's see if my computer wants to work. There we go. Let's say you want to deposit $5,000 into that checking account. It's going to return some errors because this isn't actually a thing. This is kind of just semi-pseudocode. Let's say you want to deposit $5,000 into your account. We're going to need something that allows us to do that. We're going to need some aspect of the bank account class and bank account object that says this is a real thing and you can really do this. So we'll make a first method, and actually let's do two things at once. Let's say that you also want to withdraw after that. You want to deposit 5,000 and then withdraw 500. We need methods that actually allow you to do this. So if we can just say public void deposit, because we need to be able to deposit things, and we can say you deposit some amount of the double type, and then you'll just do like, I don't know, insert method body here. It does something, but we're not going to get into that right now because that's not important. That's not what we're really trying to worry about. And I'll just copy this and change that to withdraw. Let's say withdraw does something, and you take out some amount, and you have some method body. A parameter variable, in this case, it's the double amount. It's a variable that you declare as a parameter of a method. It's pretty self-explanatory, which makes it really awesome. Like, we have some method deposit, and we can't just say deposit like as like a method that doesn't take anything, because you don't know, if you deposit something into your bank account, you can't just go up to the ATM and like click deposit. It would ask like deposit like cash or check. You have to deposit something. You have to deposit something that has value. So that's where the parameter variables really come into play, because you need to specify what you're doing, really, what this method does. Now, not all methods have them. For instance, the accessor method. So, like, if we could make one for our bank account, we could have public double get balance. This wouldn't have anything. You would just return the balance, and let's just say it does something. Actually, that's a real thing. So, let's do does something. We'll make it nice and easy like that. This does something, and keep consistency. So, get balance does something, withdraw does something, etc., etc. So, note that most mutator methods require a parameter variable because they need something to change. So, like deposit uses amount to change whatever. And I know that's really vague and abstract, but again, I'm trying to make things apply to a bunch of different cases. Like I might not want this to just be for a bank account. I might want this, instead of deposit, I could call it like grade book or something, and then double score. I could have this modify some grade book and add a score to it for some kid. I could make this very flexible, and that's really another great part of Java. And I said that earlier, and I can't stress that enough, how awesome like making a program flexible really is. A method header contains the following parts, much like an instance variable declaration. You need your access specifier, and for these kinds of methods, they're usually public because you want to be able to use them in another class. Like I want to be able to say, like if I'm testing out my bank account, I want to be able to say, all right, I'm going to deposit X dollars in my account, or I want to be able to deposit, like withdraw X dollars, and so on and so forth. And then you usually, actually, you need a return type. So I say they usually have an access specifier. You don't actually need that. If you don't specify it, it's whatever bank account is. So like this method is public still. However, it's nice to specify it that way. You can really see, and it's helps the reader really. It helps you when you're coding. So you need a return type. So like the value, like the type of value returned, such as void, which is no return, or get balance. So like get balance, I would need to say like return. Let's get rid of that caret. Return balance. It doesn't know what balance is, but let's say balance is the value of a checking of some bank account. We have our double, we have our void because deposit doesn't return anything, it just does something to the bank account object. And then you need your name or identifier of the method. Um, and I know that like this is pretty redundant. We did method declaration in the first few lessons, but I really want to just reiterate this point because I feel that it's important to include those when and I just deleted everything. Let's control and do that. I feel like it's important to reiterate because when we add in these parameter variables, it can make it like you guys will be able to remember, all right, so I need to do these three things and then I'll do the parameter variable and add that fourth thing. So then you need the list of parameter variables in the method, if any, enclosed in parentheses. So, you need your method name and then you need parentheses to denote that, yes, inside these parentheses are parameter variables, if any. So, like, I could have multiple. I could say actually, I want to change that back to amount if it's a deposit. And then I might have, like, double time. I might say I might want to record, all right, when I deposit, I want to add some amount to my bank account and I want to record the time that someone made this transaction. I could have as many as I wanted. It could just go on and on and on and on. Um, the more you have, the more complex your method is, I suppose. Generally speaking, you could definitely make it, like that rule is easily broken, but I guess a general rule of thumbs can be broken. So kind of just to recap the whole parameter variable and the different parts of the method declaration when you're actually using parameter variables. So you're going to have your access specifier, and that controls which other methods can call this one. Most should be declared as public so that they may be called by the rest of the program. However, it may be useful in some circumstances to have private methods, excluding our named use of instance variables. So like you might want to make this private for a reason different than what we had for the instance variable. So a reason different than encapsulation. Um, you might just want it to be private because it's not used by anything else, for instance. Then you need the return type, which is the type of value that the method returns. And in the examples above, getBalance is the only one that actually has a return type. Note that void means that no return type is expected, and I know I talked about this when we did objects, but again, I just want to reiterate so we can strengthen the understanding. It does not mean there is no return type, it just means that you're not expecting one. For instance, like the objects that we do, actually they're not in here, they might be in, when we do objects, do we have it in here? No, I think I used another example. Alright, well, when we did our objects, like those don't actually have a return type when we do our constructors. So like if I wanted to make a bank account, I could say public bank account and then, et cetera, et cetera. I don't have void there because it's a constructor. There is no return type and there's not to be expected of one. That that didn't make sense. There's not really an expected one as well. Uh, so each parameter of any method will have both a type and a name describing its purpose. Um, so you're going to have your type and your identifier. All right. So our last variable that we're going to cover, I know this is a long video, but I just want to be thorough and explain everything I'm doing. That way you guys like get a complete understanding. And now we're going to move on to local variables, and these ones are, I'd say, the easiest ones to worry about, just because they're pretty simple. So a local variable is a variable declared in the body of a method. For example, let's I'm just going to use this class because it's open, but let's say I want to have some method called public double give change. Like let's say we have a cash register, and this cash register needs to calculate the amount of change that the cashier is supposed to give back to the customer. So as you can see, uh, we don't have a oh my gosh, I forgot a parameter variable. My mistake. I'm so sorry, I forgot that. Uh, we just have the method itself. So let's say we have double change equals, and then we'll have this. So payment is some value and purchase is some value. Payment is what the customer gave, and purchase is what the item cost. The change is going to be the difference between the two. We could also just say, and then we'll reset uh, the two other ones in here, payment and purchase. We don't need to worry about those again, and then we'll return change. So let's say we have this method. Let's say these have values beforehand. They're reset to 0 because it's important to reset things when you're done with them. And then we have our double change. So what makes this different than the other two is because it's not declared within a method header, and it's not declared outside of any method, and it's not declared in the class itself. Because instance variables are declared in the class, parameter variables are declared in a method header, and then local variables are declared inside of a method itself. This allows this variable to only be used in give change. So I could go ahead and say double, like if I wanted to do withdraw, I could have some double change. And it shouldn't give, yeah, there we go. I have a local variable change. I don't know what's going on here, but like if we do that, oh, it just didn't like the carets because that actually represents something. So like I could have double change and withdraw, I could have double change and give change. I could have it in every method in a class. It doesn't matter because it's local, it's only for that method. Another form of a local variable is the parameter variable itself. That's kind of confusing because I list them as three different entities, three different variable types. However, well, not variable types because the type itself is, a Java type, but three different variable varieties, and a set. But really, though, withdraw double amount. Double amount is a local variable, right? I have two double amounts in the same class, and they don't like change the outcome of the other. Like if I say deposit $5,000 or something, and then I say withdraw 200, it doesn't mess up the amount variable at all because they're separate, they're independent. So both these variables belong only to the method they were declared in. So when the method is done, they are removed. That's why like you can use them at different times or at the same time even, because they're only used when the method is used. So unused objects are removed by the Java garbage collector, and the garbage collector is a very, very awesome part of Java because it removes unused variables and unused objects and frees up space, frees up RAM really. And that means that like if I use a mount once, in a program and never used it again, it's not going to sit there in the computer's memory taking up space. It's going to be wiped by the Java garbage collector. So the significant difference between instance and local variables, I'm going to try and start my conclusion now. The significant difference between instance and local variables is initialization. Local variables must always be initialized. So for instance, parameter variables are initialized when the method is called, because you have to do something with this amount when you call it. Otherwise, it's unused. Why is it there? Like I have to say double amount. I have to say like amount equals. I don't know. I could change. I could say amount is 500, and then um, I could have like an if statement or something like if amount is greater than 1, you know, do something. That kind of thing. It has to be used, and it's initialized in the method itself. Local variables, those are initialized in the method. I can't just say, double change and then expect to return it. It's gonna initialize to 0, but I can't just say like, I can't just say change. I have to initialize it and say double change, and then it gives it a default value of 0. I don't know why that didn't change to like purple or whatever. No pun intended. But no matter. Uh, and then our instance variables. So if I have private and actually I'll just do double for the sake of everything else. Private double balance. So I could have like private double balance, and then that's returned. It's initialized like in the class. So an important note if you're using Eclipse, Eclipse denotes instance variables in blue. I don't know why that isn't in blue, but this one is, so it denotes instance variables in blue. We'll use the counter in subsequent videos, and the bank account class is just for like show and tell really. And local variables, so you have your parameter variables and your local variables themselves. Those are in kind of like a brownish red color. So like change there, and then blue. And then reserved words are purple. So reserved words are words in Java that you can't have some variable named private, because private means something else in Java. So that concludes today's lesson about variables. Like and subscribe if you found anything useful. Leave a comment if you're confused, have any questions or feedback. I appreciate feedback. And, well, I'll see you later, guys.